So we will continue now with the loops. Now it becomes more exciting. So now we look into the repetition of something, so to automatically repeat certain commands and changing the instructions in every loop. Right click on this component and enable it. That becomes light gray colored. So in my case it starts with the for loop and the error message that the number is not available. This is because in the predefined version this is disabled. This int number equals 5. That's where the error message comes from. If you activate it again, then it should work. So this number variable, now we declare an integer variable. That's why you see the int keyword in the beginning, and then the name of your variable, it's called number, and the value of the variable is the number 5. In this part we want to look into loops. There are different ways to create loops. Loops are made to repeat certain tasks again and again and again. And the basic loop is the for loop, which you see here. That's a kind of a construction, a kind of a shortcut to do many things in a very efficient way. So first of all, you declare a variable, which you already know. You say you want to have a variable I. That's the type integer, and it starts with the value 0. So that's our iterating value, so the value that we iterate through. Then we say, okay, this I is increased by 1 each time the loop runs. The short form for doing this is to write I++. You can also write it with saying I equals to I plus 1. That's the same. I equals to I plus 1 is the same like I++. It's similar to a variable plus equals to something adds something to the variable I++, or the variable name plus plus, increase it by 1. And so this means we do something starting with a variable that has the value 0, and this value is increased by 1 every time our loop runs through. And now we need to specify how often this is being done, and this is done by the middle part. So you see it's separated by this I think semicolon or something. Here you say that's the end condition. It loops until I is smaller than number. Number is again a variable that we declared in the beginning. We can also say number. Instead of number, we say it's a value, it's 6. Then I will do something 6 times. What I do inside the loop, it's just that I use this print command and I print the value of our iterator of the I parameter. Since I is an integer value, means a number and not a string, and we know from our first example you can only print strings, you have to say that this number has to be converted to a string. So it's not done automatically, you have to do this, and this is usually every number can convert itself to a string. You just need to write the name of your parameter dot to string, and then bracket two brackets, and then it converts itself to a string. And then we can print it. This means if you play it now, if you run it now, and you see your output window shows you a list of numbers from 0 to 5. In this case, the first row is the index of our list that we create here, and the second one is the number of the variable. So that's the first iteration. In programming, usually you start the first item with the index 0. Maybe, so computer scientists start counting with 0, not with 1. 0 is the first item, 1 the second, 2 the third, and so on and so on. So we said repeat it 6 times. This means we create numbers from 0 to 5 until I, or as long as I is smaller than 6. When it becomes 6, then the loop is ended. If you say 7, you do it 7 times. You could also run the loop from a higher number backwards. So if you say, I want to do it now the other way around, I want to start with the value I is 6, and I want to do it until I is bigger than 0, and now I reduce 1 in every iteration. Hopefully it works. Great. Then you start with 6, reduce the value 1, and then it's 5 and 4 and 2 and 1. As long as it is bigger than 0. If you made something wrong. So here it's, I don't know what happens. You can also use minus numbers, then it executes it also to the negative values. So that's a very, very basic declaration of a loop, the for loop. That's somehow the mother of all other loops, or probably the most often used loop. With this loop you can usually replace all the other loops, nearly always. Clear how it works? You crashed your computer? So this is very important to understand how a loop's working, because we will use this a lot of times. Because this is one feature which makes this scripting more attractive than the typical or the usual Grasshopper definitions, because to use with loops, to work with loops is usually simpler in a scripting component than to do it in Grasshopper. You may remember we have used this anemone loop component, which enables us to do loops in Grasshopper as well. But it becomes very complicated, and it works for a limited number of components, but at least from my point of view, you shouldn't extend it too much. Even if you need loops of loops of loops, and then it becomes really difficult in Grasshopper. Okay, but therefore it's really important that you understand loops, the for loop especially. We will look into other loops as well, but the for loop, it's the most important one. Okay, great. So far it's not really difficult, but it will become more difficult. Okay, so the completion. There are also other loop types, for example, the while loop. So as the name says, the while loop is doing something while a condition is true. If we run it, you have to change the number value, for example, to 0, and activate the while condition. So please deactivate the rest. So just put this /*/ syntax around the other parts of the code, or write these slashes so that only this part is active. And with the while loop, you see, if we start with a number variable, with this variable called number, so this you have now, you see an interesting difference to the for loop. In this example, the loop consists more or less only of the condition itself. While something is true, do something. And you have to take care on your own that you increase this counting parameter, so our number value, by the value 1, or you can do it also by other values, by 2. If you don't do this, your loop will run forever. So if you forget to increase the number by 1, your script will crash. That's the typical way to crash a computer. Execute a loop that never ends, because then it's doing something and you don't have any way to end this loop. Because if you say while number is smaller than 5 and your number is always smaller than 5, it will never end. So in this case, if I run it now, I get a problem. You can try it. I don't know what happens. Okay, that's the while loop. So more dangerous, because the for loop won't, so it just doesn't allow you to do such stupid things, then run it forever. So I mean, maybe you could do it also with the for loop, but that's very difficult to do. With the while loop, it's much more easy. Okay, while loop. Then a very similar thing, like the while loop, is the do while loop. The difference is, at the while loop, you first check if the condition is true and then execute the part between these brackets. With the do while loop, you first do something and execute and check in the end if the condition is true. So it's more or less turn around the while loop. So first do something and then check if you should do it once again. So what's happening, we print again these numbers. In this case, we increase our counting parameter called number by the value of 2. So we create 0, 2, 4, 6, 8, 10, 12, 14, and then it's bigger than 15, which is the end condition of our do while loop. Clear? Great. Okay. So then a second or fourth important loop, but a really important one that you should understand, is the for each loop. This is used very often in case we have lists, and lists are used very often, and the for each loop allows you to iterate through all elements in a list, which means you don't need to take care of how many items you have in a list and all the details. You just say for each element in a list, do something. To test it, we first need to create a list. So a list is nothing else than an extended variable that can hold not only one entry of the data type that you specify, but many. So it means a list of values of the same type. If you remember our string example, that's more or less the same logic, but extended to a list. So we want to use a string as data type, and we create a list. So if you use a small l, it's allowed to have the same list. Otherwise, we say my list. Don't do it. So it's case sensitive. So if the L is small, then you can use the same. It's not allowed to declare a variable with a capital L, because then it's the same as the keyword list. But in this case, it's okay. Okay, so we say we want to create a list of the data type string. The list is called list. And we say it's a new list of the data type string. That's just a little bit a special syntax, but in general you know it. So in this case it's an empty list without any entry, and you can only put in string values into your list. How to add items to your list? That's done here manually 3 times. So we say list.add, and then you say what you want to add. This is your variable. This is done instead of saying list or variable equals to something. Now you say list add a value, and then it's automatically added at the end of your list. So the first item is the first string, the second is the second string, and the third is the third string, and you add one after the other into your list. What you could do as well is to, if you want to access now, this was a question in before, an individual element of your list. So for example, if you want to know what's at the position which is set at index 1 in your list. So the second entry, index 1, you remember we start counting with 0. So if you say the first, the item index 1, that's then the second item in the list. The second one should be second string, as we added it here, and to access it you say list, and then with this these kind of brackets, and then you give the index, and then it returns you your item. That's to access, how to access a certain item in a list. And then we can just print it because it's already a string, we don't need to convert it, and you see we get the output second string. Because before in our script we accessed the boundary representation where we have seen this kind of bracket where it was filled with a 0. So the first item is then the first string where we took out the boundary representation, so our surface for the rectangle, from a list where we have had only one entry, and this was called with the index 0. And for each is
was yours the panel just showing one result, not just with
you mean here?
Yeah.
Now?
Yeah.
No strings? Yeah. Now I print only one item from the list. So I just wanted to show, I deactivated the print in the for each loop. and I printed only one item from a list, and that's why it only shows one item. If I do it as I've done it in before, now you see your 3 outputs again. This means we could do this. We could do the same thing with a normal for loop, just to show you. Bum, bum, bum. Now we do the same thing with the for loop. So just to see the difference, the for each loop is a simplification of for using the normal for loop. You can do the exact same thing with a normal for loop. There you say I have the variable I, and I say I want to repeat, or I want to increase this variable as long as it is smaller than the number of elements in my list, which I call by saying list.count. This gives the number of elements in my list. And then I increase my counting variable I by 1 every time, and then I print the corresponding item in a loop, corresponding item of my list. So you see, you get the same result at the second time again. Sixth component, so the second last one, this one here, please enable it and open it. And there you see the introduction of the if and else if and else conditions. So now we ask, or we use these conditions to ask if something is true, and if yes, we do something, and if not, we can ask if something else is true, and if not, we can do something else, or we just can continue with the code without doing anything. That's the idea of the conditions. I will only introduce you the if condition. There is also another one. If you have many if and else if conditions, you can use the case keyword. So there is another way, instead of using these if conditions, but at least I use it very, very rarely. That's the switch construction, which says you have a certain value and you create this switch and cases. If this value is 1, you do something. If the value is 5, you do something else. It's very, very similar. It's just a different way to write something. In our case, I think we'll never use it, but if you ever see something that is called switch and case, please remember it's the same as an if condition. So we start in this example. With declaring a value, which is probably also not a good idea. You should call it my value, because as I've seen now, it's a keyword, but obviously it works. Anyway, so a variable, an integer variable, where I assign a value, which is the result of a division, 14 divided by 2, 7. And then we can use the if condition to to ask what, I mean, we use this just as a test case. We say if the value is not 5, so the Ausrufezeichen, do you know it? Sorry? Exclamation mark. The exclamation mark. Thank you. In front of an equal means not. So this means not equals 5. And if the value not equals to 5, the condition, so this is true. Which means, so you run into this part if the condition is true. So if the result of this request is true, then we print that, in this case, I zoom in. So we say I want to convert my value to a string, and then I add to my string this part, and then my output is 7 equals to 5 is not true. Interestingly, if I say 13 divided by 2, what happens? 13. That's boring. How can I go to this? So, since we use an integer value, floating point numbers are not possible, but 13 divided by 2 would be 6.5. So now what happens? The compiler decides to cut away the floating point part and only uses the 6. So there is no rounding. Also, if it would be 6.9, you would get a 6, because integer just takes the number in front of the point, the integer part, the floating point part. So in this case, we run into we ask if the value is not 6. So this is not true because the value is 6. So we go to the next step. We say else if. So we just ask if the first condition was wrong, maybe the second is true. Let's test this one. If the value equals to 6, then we see, yeah, great, it equals to 6, because now we see 6 equals to 6 is true. That's what we write here in our print, the value itself plus the rest.
If we put the value as 10,
sorry?
10 instead of 13.
10 instead of 13. Then I run into the last part. So first I ask if the value 5 not equals to 6, which is, okay. Interesting. Yeah, now it's again true. But if I would do it like this, it's wrong, and then I would get a very strange result. I don't know why I've done this. So now I run into the first part. The value equals to 5. This would be true. But since I ask if it's not 5, just change it. I don't run into the first one. I ask if the value equals to 6. That's false again, so I don't run into this one. And then there is else, means all the rest. All the rest, in this case, I mean, is true, is always true. So if nothing else is true in before, you run into the else part. And this gives you then this result. But in before, I've written false because I've tested it like this. And if I put in here the 7, I think this was my first example. Anyway, I mean, this is just a stupid example. You should understand that you ask first something with the if condition. Second, you ask, I mean, you can repeat this here many times. You can say else if as many times as you like. You can do this hundreds of times, asking always else if, else if, else if, until you run into one of these branches. And after this, your code jumps automatically to the end of the whole construction. So only one of them is executed. So you never execute the else if it was true in before. This is only executed if nothing was true in before. Yeah, what is it? Interesting result. Even if you say that your value shall be a double value, but if you use only integer value to make the computation, so 13 and 2 are two integer values, and if you divide 13 by 2, it's clear, it should be 6.5, but what you can read, the output is 6. Also because I used the double value, so what's happening here? As long as you use only integer values in a formula, you receive an integer value. If you want to have 6.5, you just have to change this to 2.0 and then you get 6.5. Because only if one number in this equation, in this formula, is a floating point, also your result will be a floating point. Don't ask me why. So we go to the third component where we find, or there are two parameters linked to it. There is again loops, so please enable it so that you will see this line structure. So we use these iterations. That's just a variable that tells us how often we will do something in our loop later. You can change this. 26 is the number of lines that you will create. So these are 25 lines now. In this case, we use these x and y double parameters as input from our sliders in this case, from here. And we assign them to other parameters. So this is a little bit meaningless because we could also directly use x and y, but just for the intention of this example, we use the frequency and intensivity of this function that we will use. So it's just a renaming of a variable. If you are not happy with the name of a variable, you can rename it. It doesn't change the values. Okay, now we use a collection, a list of lines. So you remember we have used a list of strings in before. Now we say we want to use a list of lines. So the data type is in this special kind of brackets. This is always the data type that you can use for your list. So in this case, you are only allowed to put lines into your list, nothing else. You cannot put a string into the list or a number, only lines. I give my list a name. It's a collect lines list. And now we see the first for loop. We use again this declaration with the variable I equals to 0, I. So the for loop is executed as long as I is smaller than iterations, which is 25, and I is increased by 1 in every loop. So in order to create a line, we again need 2 points, the start and the end point. I call it again from and to. PT means point. And what you see here, I use this variable I to define, in this case, the x coordinate of my point from which I want to draw my line. So I just use this I plus 1.5, means I add a value each time to have a small separation between the lines. That's the x coordinate. So that's here at the bottom line. These are the 25 x coordinates. Then for the for the second point to which I want to draw my line, I use the I coordinate again for the x coordinate. Why is this done here? Interesting. So I draw my line to a point with the x coordinate I and the y coordinate, which is I multiplied by I divided by 10. So that's just a weird formula. You can choose something else. This defines this exponential growth curve. Okay, and the rest you already know. You create the line. So you have the data type line and you create one line called my line. And this is a new line from point to point. And here you add this newly created line to your list. And before we added string values to our list of strings, now we have a list of lines and we add a line to our list. We need this collection because at the end of our code we want to return all lines to our output value, output parameter, and we do this by using a list. So then at the very end we can just submit a list of lines. Okay. Sorry, there was some weird part that I've used just to show you how to manipulate the items in a list. But if you deactivate the second part, that's better for understanding the first part. If you just look into the code until here, here I've deleted this I plus 1.5 because I wondered why this worked, but now it's clear. So you start, of course, always from the same x coordinate because our lines are vertically, so they have the same x coordinate, only the y coordinate is changing. For the first point it's 0, and for the second point it's this exponential growth using this I as a value. Is it clear so far what's happening in the for loop? So you create 25 times a line and put it into a list of lines, and this list is then sent to your output parameter A. So basically, what we've done is we've used this iterating variable I to define coordinates of points, and these points were used to draw lines. Very, very simple. We can do now something more sophisticated, just to have some fun here with these functions, to use sinus and cosinus. I hope all of you are familiar with these functions. Therefore, we introduce this frequency and intensity parameters to draw these funny functions here, which means we use or we manipulate the starting and end points of our curves by this cosinus function, respectively for the second point by the sinus function. So now we've combined the cosinus and the sinus with different intensivities, so the height of these curves. So you can play around with these values just to experiment a little bit with it. I mean, if you take away this part and having it with a 0, then it starts always from the horizontal line. If you replace it with this cosinus function, you get this if you multiply it by 2, you can change the start and end point. So in the end, you create always these curves, but you use the values as start and end points. You could also connect the lines itself. I'll do this. So just play around a little bit with these values to get an idea what happens, especially what's the role of the I parameter, because this is the control of everything. So you manipulate after every iteration the whole result of start and end point based on the increment of the value of the parameter I. This is the only thing that's changing. But you can do a lot of things with this change. So just because you increase I by 1 every iteration, you can draw many different things. Okay, any questions? You're hungry. So before the lunch break, we only do one thing. We want to manipulate the items in a list. In this case, we want to manipulate our lines, so the start and end coordinates of the lines. This happens in the second part. So if we uncomment, so here, it's also in the headline, we manipulate properties of an object. In this case, objects that are stored in our list. Therefore, we use this for loop now to take out individual lines, so items in our list, which are lines, and do something with these items, with these lines. So collect lines, you remember this was the name of our list where we added the lines in before. Now we say I make a temporary variable, so a cur line, which I use for current line, which is data type line, of course, and I use this syntax to access an individual item in a list of items. Of course, you have to be aware that you use lines. If you say this is an int, then it doesn't work. Then you get an error message telling you many things, especially that there is no implicit conversion from type Rhino geometry line to int. Yeah, that's the reason why it doesn't work. So I cannot convert a line to an integer value. Okay, so I take my line, and what I want to do, I want to change the coordinates of the points from to the line is drawn. This means I take here, again, I take out the point from the line, so you can access the point to which a line is drawn by using the name of the line, so curline dot to. This is a property now, so the first time we use this property, which you can see also here from typing curline dot. Then you see the properties are these elements with this hand holding a piece of paper or whatsoever. That's a property. The red cubes, these are methods. So this means you have the property bounding box, which would return a bounding box. You have the property direction. And here you have the property from x, from y, from z. So from would return the point from which a line is drawn. From x would only return the x coordinate from which the point is drawn. And you could also have the length of your line as a property, and here that's what we used. We have the to property, which if you click on it, you also see this hint, the intelligence that says what you will return from this property is a point 3D. And this is the endpoint of your line segment. So this editor tries to support you a little bit with telling you what's in this library.
Why do we start with the endpoint?
Sorry?
Does it matter if you start with the endpoint? Because we start with the endpoint and we start from the line. It doesn't matter.
You can do whatever. You can also start with the endpoint, which would be then the from or the to. You just need to remember which is which. So here I have the temp pt and the temp pt from. You have to know which point is from which property of your line. And only now you can manipulate the point itself. So now you can say I want to change the x coordinate by adding 1 and the y coordinate by adding 2. And I want to manipulate the other point by subtracting 0.5. So these are just random numbers without any meaning. And after you have done this, you need to assign these temporary points that I've manipulated again to the end and start point of your line. Unfortunately, you cannot manipulate these points directly. There is some security in this coding that doesn't allow you sometimes to manipulate certain properties or objects. Therefore, because otherwise we could also say current line dot to dot x, so we could manipulate the x coordinate of this point directly. But here we need to create these temporary points in between. And in the end, we have to assign the temporary point back to our curline to and curline from points. These are these two lines. And we need to update the item in our list. That's a little bit special here because often it's a reference. Often the list knows that its objects have been updated. In this case, it doesn't know it. So we have to say the item where I have taken my object out of my list need to be replaced by this updated object now. You have to do it in this relatively complicated way because you cannot access these values of objects in a list directly. And since we changed this, you can change these values a little bit. If you say 5, then you can move around these objects based on your manipulations. And it still reacts to your sliders, so if you move the sliders, you have here these moving elements based on the frequency and the intensity of your sinus and cosinus functions. So you can create funny patterns.